In this video, we're going to learn about density. It's the amount of matter that's in a given volume. So if we look at these two pictures here, we can see that the one on the left has much more matter in the same amount of volume than this one on the right. So that means that this one here on the left has a higher density than this one on the right. So we're looking at the amount of stuff that makes up a given volume. And the formula is density is equal to the mass divided by the volume, and that formula is in your reference packet on page 3. Density allows for things to float. So if something is less dense than something else, it will float. So here is a density column, and you can see that the bolt down here is going to have the highest density. And then as we move up, we can see that the popcorn kernel is going to float on top of the corn syrup. So popcorn kernel is less dense than the corn syrup. We've got water up here in the middle. It is less dense than dish soap or a cherry tomato. We've got some beads in here. We've got vegetable oil. Notice that the oil is less dense than water. We've got a soda cap in there, some alcohol, lamp oil, and on top we've got the least dense is our ping pong ball. Now we can rearrange this formula, and that's going to be very useful for us. So if we start with density is equal to mass over volume, we can rearrange that. Mass is density times volume, and oops, that should say volume, that should say mass over density. I need to change that real quick. There we go. Okay, so mass over density. Now, for units, we tend to use grams. For mass, for volume, you'll see either milliliters or cubic centimeters, and those two are equal, so you can interchange them. Now, in your reference packet on pages 1 and 2, you're going to see that you can find the densities for some of these materials. So this is page 1. You can see density down here at the bottom. And this is page 2, so we have density here for organic substances and density here for inorganic substances. And water is down here at the bottom, so you can see that. These were metals over here. So here's a practice problem. We've got a block of metal that occupies a volume of 15 milliliters, weighs 40.5 grams. So what is its density? What's the metal? Well, our formula is density is equal to mass over volume. So our mass is this guy here in grams, and we're going to put that over our volume. Now volume is in milliliters, so we're going to pull that down there. The units in the problem are going to help you determine where they go. So you need to remember that grams is going to be mass, and milliliters or cubic centimeters is going to be volume. So when we put this in our calculator and we divide this out, we get 2.7 grams per milliliter. So notice that we've combined the unit here for the unit for density. So we want to know what this metal is. So we go to our reference packet. We know that it's a metal, so we're going to look down here on page 1, and we see right off the bat here that aluminum has a density of 2.702 grams per cubic centimeter, which remember is the same as grams per milliliter. So our metal in this problem is aluminum. Our next practice problem, what is the mass of ethanol that exactly fills a 200 milliliter container? So we start by rearranging our formula to solve for mass. Now one thing that's going to help you, and I should have done this on the last problem, one thing that is going to help you is that if you underline, ooh, that's a big line, if you underline the things that you have and maybe circle or otherwise, here we'll highlight, that'll work. So we have milliliters, and we know that that's a volume, and we're looking for mass. Okay, now we know that our formula is mass equals density over volume because we've rearranged, which means we need the density of ethanol. So we go back to that reference packet, and right here we can see ethanol, and it has a density of 0.7893. So let's pop back down to our problem here. So mass is density times volume. So we plug our numbers in here. So 0.7893 is our density, 200 is our volume, and we solve that and get 157.9 grams. In this next problem, we see that we have a metal shot, which is just like a BB, I guess would be the best way to think about it, and it has a mass of 28.5 grams. It's added to a graduated cylinder containing 45.5 milliliters, so that's a volume, of water. The water level rises to the 49.1 milliliter mark. From this information, calculate the density. So we're trying to find density here. Sorry, this looks sort of weird. And we're going to identify our metal. So what we need to, what we need to do is look at our graduated cylinder. All right, so 45.5 is where our water level rests. Make sure I can find it there. All right, so right there, we put our object in, and the water level is going to rise. Let me see if I can find where I put it. Should be right around here. Sorry, I'm doing this without my good technology. Anyway, the water level is right about here, 49.9, which means we're going to have to do some subtraction. All right, that water level rises. That means that the object itself is 3.6 milliliters. So anytime you're given two volumes like that, you need to subtract them. So we pull our mass down, divide it by that 3.6 for the volume, put that in your calculator, and you get 7.92 grams per milliliter. So if we look back at our reference packet down here, we can see that iron is 7.86. So that is what we have. Here we go. Let's get it all back. So iron is what we have in our BB. Now the last thing you can do with density is you can interpret a graph. So we have a mass as our x-axis and volume as our y-axis. So we know that density is mass divided by volume, so all we have to do is find the slope of the line to find the density. So to do that, we just simply pick 2 points. So I'm going to pick this point here at 400 and 400, and I'm going to pick this point here at 100 and 100. So that gives me basically 300 divided by 300, which is 1 gram per milliliter. So if I look back at my reference packet, I've got to find something that has a density of 1. So because I know where it is and what it is, I can look and see that I have water with a density of 1 gram per centimeter cubed or gram per milliliter. So that tells me that this is going to be, well, let me let you see it. This is going to be water.